Yes, my presentation topic is Introduction to Memory Forensics. And I'm Sai Nivedita, intern at VIEH group. And these are the contents which I'm going to discuss in this presentation. What is memory forensic? What is the need for memory forensic? And types of memory? What are the information available in RAM? And the two important processes of memory forensic, like memory acquisition and memory analysis, and what are the challenges in memory forensic. So let us start with what is memory forensic. Memory forensic is basically a process of examining volatile data found in computers' memory dump. Volatile data usually exists in physical memory or RAM. It is the information which wipes off when power is plugged out from the running system. So it stores the information such as process running in the system, the network connections, and this information describes the state of the system at the time of live response. So it is performed basically to examine and discover attacks or malicious activities which does not leave any traces on hard disk data. So what is the need for memory forensic? Memory forensic is used helpful in reconstructing the original state of the system, and it determines the process, network, and registry activities running in the system, and it helps in finding and extracting forensic artifacts, and it also helps in finding malware which is persistent in the system. And types of memory. And coming to types of memory, there are two types: volatile and non-volatile memory. Volatile memory, it will wipe off when power is plugged out from the running system, like it is a temporary memory. And non-volatile memory means it will be static, like persistence, even if the computer is powered off. And volatile memory example is RAM and cache memory. The examples of non-volatile memory is floppy disk, compact disk, hard disk, pen drives, and SD cards. So next is the information available in RAM. What are the information we can get by analyzing or acquiring the RAM? We'll get process and driver information. What are the loaded modules? The runtime information, like how much time the system is active, who are all the logged in users, and the password for the user accounts, and what are all the files open and unsaved documents, network information, and even BIOS memory is also available in RAM. And next we'll discuss about what is memory acquisition. Memory acquisition, it is of two types. One is hardware-based acquisition and software-based acquisition. In hardware-based acquisition, it is depends on direct memory access. Direct memory access, it means there will be a direct connection established between input and output devices with memory, and it can be established by using a DMA controllers. So hardware-based acquisition can be used by in only DMA-enabled systems like FireWire and hardware like Capture Guard. So like what is the main disadvantage of this hardware-based acquisition is this hardware-based like this FireWire and Capture Guard hardware should installed prior in the system to capture memory. So it won't be possible like in a victims, we have to acquire a victim's memory dump. So by using hardware-based acquisition, we can't expect a victim using FireWire and Capture Guard. So it won't be possible in every case. And next is software-based acquisition. Software-based acquisition method mainly it copies the content of the physical memory into drive with using memory acquisition tools like FTK Major, Magnet RAM Capture, Belkasoft. These are all the tools used in Windows to capture memory. It is also software-based acquisition, also called memory dump. Here in image in the right side shows the interface of FTK Imager. When you open FTK Imager, you can find a option like file. When you click on file, you'll get an option capture memory. When you click on capture memory, you'll get a tab showing which asks the destination path, which path from where you have to store that memory dump, and the destination file name. Then you click on capture memory and it starts capturing memory. So this is software based acquisition, basically by using certain tools to acquire the memory. Next is memory analysis. Memory analysis is again of two types, like live memory analysis and memory dump analysis. Live memory analysis, it is for manual examination of running process, their memory contents, and what are the network connections are running in the system and the current system state. Like there will be situations like uh, the investigator won't have enough time to acquire a memory dump, and in that situations live memory analysis is the best preferred option. So there are many tools used on Windows for live memory analysis, and one of the most famous tool is Process Hacker. When we run Process Hacker, it automatically shows what are all the processes running in the system, and when we switch the, we can also switch the tab for services, what are the service running, what are the network connections, and the disk used by that processes. We can see all these details by using Process Hacker. The next is memory dump analysis. Memory dump analysis is an essential element in incident response process. So when a memory dump of a compromised machine is created, it is helpful in reconstructing the activities performed by attacker on the machine, like what all the process he accessed and what are the if we did any malicious activities, we can even find out using that memory dump. So for memory dump analysis, mostly used tool is volatility framework, which is the most popular tool for memory dump analysis. Basically, it is a command line tool. So if you run volatility in Windows, you need a Windows PowerShell or command prompt to run it. So why volatility? What are the main features of volatility is it is a single cohesive framework, which means it analyzes memory even in a 32-bit system or even a 64-bit system, and even in Windows, Linux, and Mac systems, and even from 32-bit Android. So the volatility is designed. It supports new operating system and architectures as they are released, and it is open source GPLv2. Like like the source code is available freely, and you can even extend it by learning how volatility works. And it is written in Python. Uh, Python has loads of libraries which helps in forensic and reverse engineering. So that Python can easily integrate into volatility, and it runs on Windows, Linux, or Mac analysis systems. So like these volatility is compatible with all the operating systems, and it is focused on forensics, incident response, and malware. Like in volatility, we can even find unallocated storage, indirect artifacts, and so on, which is helpful for forensic analysis. And even we can find the malware persistent in the processes. So, and the next feature is comprehensive coverage of file formats. by using volatility, we can analyze raw dumps, even crash dumps, hibernation files, suspended VM files, and even other formats also. You can even using volatility can convert back and forth between these formats. And the next feature is extensible and scriptable application programming interface. So for example, if you use volatility to drive your malware sandbox, it performs virtual machine introspection, and you can even explore memory in automated fashion. These are all the important features of volatility. And now let us proceed with a demo by using volatility. There is a scenario where computer is suddenly behaving unexpectedly. So we have to find out the reasons whether the machine is infected with the malware. So if it is infected, what is the process ID of that malicious process? What is the malicious process running? What is the process ID allocated in the system? And what is the name of the malicious process which is running? So these we can identify by using volatility. So here I use the Sift workstation to analyze the memory dump of a sample name called Perseus.vmin. So first we have to install volatility. Then after installing volatility, you have to give command cd volatility to run in volatility folder path, and then give the command as python to vol.py -f, and the path where you store the memory dump, and image info. Image info gives you different profiles based on KDBG search. Like each profile mentioned here as a unique name, which is derived from its operating system name, its version, service pack, and architecture. For example, here there is Win7SP1 into 86. It is the name of a profile for a 64-bit Windows 7 service pack 1 system. So these are the image. This is the information we can get by using image info plugin. So we can choose any of the profile to carry out further analysis. Here I choose Win7SP1 into 86. So by using plugin like ---- profile Win7SP1 into 86, the plugin is PS list. PS list, it lists what are all the process running in that system by walking through double linked list. Here the image which is showing eProcess head, eProcess, and eProcess tail. This is the image of a double linked list. Double linked list is basically a circular list which points to both the process before it and process after it. eProcess is a data structure which point out various attributes of the process like process name, process ID, parent process name, and its creation, exit time. So these are all stored in eProcess structure. So PS list plugin will walk through this structure and find out what are all the process before one main process and after that, and it will list all the process running in the system. Here, when we execute this PS list plugin, we'll get all the list of the process running in the system. So here svc host double.exe and suc host double.exe is identified as a malicious process because that original legitimate process name is svc host.exe. Here in this chart, you can find out all the names of the process running which run in the system. So it is svc host.exe, not suc host or svc host double.exe. So exe files mainly have single dot extension. So here the malicious process have double dot extension. So this is identified as a malicious process, and its process ID is 3832 and 3924. And the next plugin is PS3. In PS3 plugin, it will displays all the process with a hierarchical manner. Like it shows the parent-child relationship. What is the parent process of particular process? What is the child process of that process? So when you look at this chart here, you can see system is the main process, and this smss.exe, it has a parent process of system. Like that, there are certain process with child process and parent process. So PS3 plugin will show the parent-child relationship, parent-child process relationship, and it also walks through double linked list and displays all the process in a hierarchical manner. And the next plugin I used here is PSCAN. PSCAN plugin, it scans the e-process objects in kernel memory instead of relying on double linked list. Because PSCAN displays even terminated or hidden processes by following full tag scanning. Like whenever a process is created, a process memory is allocated in the virtual memory. So for each process, there is a full tag is given. That full tag name is proc. So this PSCAN will use that full tag scanning technique, and proc is like by using that full tag scanning technique, it even identifies the hidden process, even if the process is hidden. Like when a decom attack is performed, like direct kernel object modification attack is performed, that attack unlinks a process from the double linked list. So this is a normal double linked list before decom attack. When the decom attack is performed, it unlinks one process between from the double linked list, and even if that process is unlinked, it has a process tag like proc. So with that full tag scanning approach, we can identify even hidden or terminated process. And after performing pscan plugin, we can create a dot file of the pscan plugin output. That is, output is equal, by mentioning output is equal to dot, and output hyphen file is equals to sample name, whatever name you have to allocate, you can give. I gave here as purchase dot dot. So it will create a purchase dot file based on the pscan plugin details. And by using some online converters, you can convert this dot file into PNG. By that, you can see the hierarchical list of pscan, what are all the process which are running, even the hidden if there are any hidden process, or if there are any process exited from the system which are not visible in through the ps list plugin, even they are also visible using this pscan plugin. So next plugin I used is proc dump. Proc dump will dumps the particular process. Like we identified two processes as malicious in previous slide, that is svc host double.exe and suc host double.exe. Here I mentioned the process ID of both the process, and by using proc dump plugin, I dump the process. So it will dump the process in executable format. We can use these executable formats to upload in virus total website. It will show whether the process is malicious, flagged as malicious or not. Here I uploaded one of those process and it is showing 48 vendors out of 67 identified it as a malicious process. And the next plugin I used is handles. Handles, basically they are the open instances of a kernel objects, that is files or registry keys, process threads. So to identify which object is being accessed by a malicious process, we can use this handles plugin. It displays all the objects accessed by a process. So here handles plugin along, we can filter. If we use only handles, it will displays all the process handles. So to specify particular process, use filter such as -p 38 and mention what are the process you need to find out. So that process ID. And next plugin I used is handles with mutant. Mutant is basically created in a system to make sure only one instance of that process is running. If there are some process, for example, Windows Media Player is there, it can run only with one instance. If it is running with multiple instances, then it is flagged as malicious. So such, if there are any such process, then with mutant can identify, with mutant we can identify whether it is a malicious or not. So here I use mutant plugin, and then I used Hive list. Hive list basically used for accessing registry hives. So these are all the registry hives associated with this profile. And next we'll see what are the challenges. Challenges of memory forensic. Like in memory forensic, basically RAM is a useful and extremely fragile thing. So any interaction with the system can lead it to irreversible consequences. So the main important challenge in memory analysis is data preservation. Like when we are creating a memory dump, we, like most of the operating systems do not have built-in solutions or tools for creating memory dumps. So whatever tools we are using, they're not guaranteed 100%. We are not overwriting the data in the RAM. It sometimes even corrupt the system. Like we may see that blue screen of death, BSOD. So the investigator should consider when choosing a tool, like what are the changes it is making to the system, what is the possibility of creating a dump. And in critical systems, running these tools for capturing memory dumps sometimes can cause an overload. So when investigator has to decide what are the tools he is using, and the system under investigation, it is a critical object. So disabling or corrupting the system could lead to loss of important data and shutting down of critical process running in that system. So by keeping all these pros and cons in mind, the investigator has to decide what are all the tools he has to use. And there is one more challenge is instability. Like whenever the system under investigation, basically if it is affected with a malware, it will be unstable. In such situation, creating a memory dump could also lead to unpredictable consequences. Sometimes even malware tries to use anti-forensic techniques and prevent memory preservation. So by taking all this into consideration, the investigator has to carry out memory acquisition process and memory analysis. So this is it from memory forensic, and thank you.